Hello, my name is Niall and welcome back to Open Woods. So today I just want to share the notes I've made and the research quickly on MASPO, especially around open source language models and how to better optimize them. Okay, so just a quick run through of MASPO generally. I just want to talk about what is MASPO, how can MASPO help me achieve my project goals, and then how do I implement MASPO effectively. Just having a quick look, this is the primary research paper which we'll be basing our notes off today. I do have a further link for references and further reading, which has kind of extended off this initial research paper. Of course, I will leave all that in the description of this video if you would like to kind of dive a little deeper yourself. So let's just have a quick overview of what MASPO is. Quick TLDR, it is a joint prompt optimization for large language models based around multi-agents. So it is a framework designed to help improve how teams of AI agents work together. By the end, you should hopefully be able to understand how to essentially build and fine tune a team of AI agents. Okay, so let's have a look at common errors. These are errors that I specifically fell prone to, and this included optimizing agents one by one instead of looking at a global chain. So let's say, for example, I was vibe coding or had a little hobby project that I wanted to complete. I was essentially using one AI agent to complete that whole process instead of like splitting it down into multi-stages for multiple AI agents. Okay, so happy results by the end of the video. Hopefully you should be able to chain together multiple AI agents and complete complex tasks more effectively. Okay, so let's just have a look at what MASPO is. Well, the way I like to think about it is I come from a radiography background, so biology is kind of my bread and butter. So the brain extends into the body through the spinal cord and then connects to a system of organs. And the quality of the message reaching these organs is determined by the quality of the logic leaving the brain and the quality of the spinal cord. If either are damaged, the signal is poor. So this makes sense. So if you have a poor input and a poor logic and reasoning, well, then the output is going to be subpar. So within AI and large language models, this is kind of referred to as the butterfly effect, which I learned. And this is a tiny change in the first agent's prompt, which can lead to total hallucination or failure by the third agent. That input is then passed on to a second agent. That second agent is flawed and has a break in the chain, essentially. And then we'd start to have hallucinations, and then the final output is garbage or AI slop. So another term for this is prompt brittleness. So just quick bit of math. If you want to try 10 different variations of a prompt for 5 different agent models, you'd have to test 10 to the power of 5, which equates to about 100,000 different combinations. So essentially, as the prompt or AI agent increases, so too does the logic tax. Another critical error with increasing your AI agent models is that the bigger the chain, the more difficult it is to diagnose fail points. So, for example, it would not be correct to place blame on the last model who has essentially created the output. So instead, we should look at each agent individually and analyze the chain rather than the final output. So, fun fact, this is how the brain learns. So if we look at neuroplasticity, whenever you catch a ball, the brain has to figure out which neurons worked and which failed. Those that worked are strengthened, the others are killed off. Pretty cool. So the ideal of MASPO is not to care about individual prompts, which I have felt very guilty of, kind of fine tuning and trying to find the perfect prompt. But instead, it's to focus on the end state. Has the final output met the needs of the user? And so how this can be evaluated is through the chain test. So the chain test includes agents A, B, and C, and a score is then determined by a critic agent, providing a score out of 100. If the score is high, a conclusion is made that the chain of prompts was successful. That prompt is then processed and sent on for the final output to be carried out. Okay, so the evolutionary beam search. So the research paper kind of described that final prompt as the beam. It is the final source of truth. Again, so just flip it back into biology mode. This is kind of like natural selection, but for prompts. A single prompt is iterated to create multiple versions, mutations, and these mutations are tested and weighted. The top performing prompt, the beam, is the final result. So think about it like a tree. The healthy growing branches keep growing, while the dead and weak branches are pruned off. So this research paper went on to find quite successful results and real world impacts. So it was treated and tested on real world projects within coding, reasoning, and creative writing. The MASPO optimized team of AI agents performed significantly better compared to the teams using single prompts. 3 MASPO agents sometimes develop their own shorthand to communicate more effectively, which kind of blew my mind. I think that's pretty crazy. The AI agents are starting to kind of create their own little shorthand, their own little keywords to kind of speed up and evolve the process. Pretty cool. Okay, so that is everything for today's short video. I hope you learned something. It was pretty fun to dive into myself. And I've kind of been experimenting with chaining together AI agents to kind of break more complex problems down into smaller ones and starting to see some better results. I will be leaving links to the research paper itself and further reading if you would like to dive deeper. Thank you again for watching.